Do you find yourself doing this a lot too? A really great idea suddenly pops into your head? Like, hey, I could set up an automatic watering and grow light system for the plants on my balcony. Or, what if I retrofit that ancient machine in the workshop? But just the thought of having to learn PLC ladder logic or struggle through that C code, which looks like total gibberish. Boom, the excitement just disappears. And just like that, the idea stays buried in your notes forever.
What you're describing is basically the ultimate roadblock for anyone who wants to build something themselves. Between creativity and execution, there's always this huge mountain called the technical barrier.
So today we're going to talk about something that might actually solve this pain point. The main character is an IoT automation controller called IOTAutoMate. Its most eye-catching slogan is "No programming required. Do everything with a mobile app." So our mission this time is to really dig into this controller and see whether it's genuine black tech innovation or just another, well, overhyped marketing line.
The materials we have on hand are actually very comprehensive. There's the official website, feature descriptions, very detailed hardware specifications, and even an MQTT protocol document specifically for developers. Pages and pages of it. Looks very professional.
Yeah, I saw that document too. First glance, honestly, it was a little intimidating.
So our goal is pretty clear. We're going to break all this information down and see whether its claims of being easy to use and quick to deploy actually hold water. Most importantly, we want to help you figure out who is this really for and what real problems can it actually solve.
All right, let's start with its boldest promise, application deployment in as fast as 1 day. To be honest, my first reaction when I saw that was, come on, really? 1 day? From idea to a fully running automation project in just 24 hours? There has to be a catch. What exactly do they mean by deployment? Does simply powering it on count? Or are we talking about a fully debugged working system?
I had the same question at first, but after digging deeper, I realized the logic behind it is actually a shift in philosophy. What they mean by no programming is that everything is done through visual configuration in a mobile app.
Visual configuration.
Exactly. Think of it like playing with building blocks when we were kids. You don't write if this then that code. Instead, you create automation tasks directly in the app, then add conditions and actions. For example, if soil moisture drops below 40%, turn on the water pump for 30 seconds. The condition is soil moisture less than 40%, and the actions are turn on the pump, delay for 30 seconds, then turn the pump off.
Ah, I get it now. It's basically translating programming languages into plain human language.
Exactly. And on their comparison page, this difference becomes even more obvious. With traditional PLCs, you have to learn ladder logic. With microcontrollers, C is the basic skill. Their goal, instead, is to let an electrician, or even a farmer who understands agriculture really well but knows nothing about programming, can get started quickly.
So when they say 1 day deployment, they mean.
They're assuming the hardware wiring is already done. Under that condition, someone with zero programming background can finish the logic setup, debugging, and get the entire system running within a day. Compared to the traditional approach, which often takes weeks or even months, that really is, well, disruptive.
I see. So they're basically taking the most time-consuming mental work.
Programming and debugging.
Right, replacing programming and debugging with something much more intuitive. But that raises a question. If it's this simple, are the functions watered down? Is it actually powerful enough? What can it even connect to?
I looked into that for you. Its nickname is the Universal Controller.
How universal. That's a bold claim.
It is.
On the input end, it supposedly supports 95% of all sensors out there. I went through the list, and the range is massive, from the little PIR sensors on your front door to heavy-duty industrial-level transmitters, and even soil sensors for greenhouses. It takes them all.
Wow.
Which means that no matter what physical quantity you want to monitor, you can basically find a matching set of eyes and ears to plug into it.
What about outputs? What can it control?
The output side is just as diverse, from something as small as a solenoid valve controlling water flow to large three-phase motors in factories. But the most interesting part is its fine-grained control capability. It's not just simple on and off.
Oh? What else can it do?
It can smoothly adjust the brightness of plant grow lights like a dimmer switch, or precisely control the speed of a stepper motor on a conveyor belt.
That's impressive.
And that's really its core value, the breadth and depth of its ability to connect and control. It's trying to become a general-purpose translator of the physical world, and through its IoT features, actually make true connectivity between everything a reality.
Translating all kinds of physical world signals into switches and sliders you can operate in a mobile app. I really like that analogy.
And if we dig one layer deeper and look at the company behind it,
Shenzhen Yuanlai Intelligent Equipment Co. Limited.
right, you'll find a very interesting combination. The core team comes from Alibaba and Huawei.
Alibaba and Huawei.
Yes, that background alone is quite convincing. It represents consumer and IoT-oriented software thinking, Alibaba's strength, combined with industrial and communications hardware expertise, which is Huawei's DNA.
Ah, the ultimate combo, software plus hardware.
And this philosophy is perfectly reflected in the product itself. It uses the simplest possible app interface, that's the software mindset, to control extremely stable, reliable, industrial-grade hardware. So it's not just a hardware company anymore. It's more like a company that truly understands user experience, except that its products just happen to be hardware.
That makes sense. And the materials mention that they're a board member of the Shenzhen Facility Agriculture Industry Association. No wonder so many of their case studies are focused on smart agriculture. It shows they've gone deep into real industries to refine their product.
Exactly. This isn't something dreamed up in an office.
All right, solid hardware, a modern software mindset. So as a user, before I make a purchase, what's the very first thing I need to do? The documentation mentions several different versions and paths, and honestly, it sounds a bit complicated.
This is actually the first fork in the road they designed for different users, and one of the smartest parts of the design. Your first decision is how the device connects to the network. There are three options. The first is the Bluetooth-only version, which runs completely locally with no internet connection.
What's the advantage of that?
Fast response and absolute security. It's ideal for scenarios where you don't need remote access and just want quick, reliable automation control.
Got it.
The second option is the Wi-Fi plus Bluetooth version. That one's easy to understand. It connects to your home router and lets you control your devices remotely from anywhere.
The most common setup.
The third option is the 4G plus Bluetooth version. This one is designed specifically for remote or outdoor scenarios, things like smart agriculture, intelligent transportation, or water conservation projects.
Ah, built for field deployments. What's next?
Then you reach the second fork in the road. Which path will your data and control logic take? They've prepared two completely different highways for you.
Highways?
Right. The first route is integration with the Tuya Smart Ecosystem. You can think of it as a ready-made free public highway.
I've heard of Tuya. It's a pretty big IoT platform.
Exactly. Its biggest advantage is convenience. Your controller can interact with tens of thousands of other smart devices in the Tuya ecosystem. Cameras, curtains, speakers, you name it. You can literally say, Tmall Genie, water the plants, and it just works.
Wow, that's perfect for regular households and DIY users.
Precisely. This path is designed for users who want fast remote control without a lot of tinkering, everyday consumers on the C side. It's also great for traditional manufacturers who want to quickly upgrade their products with smart automation.
And the other path?
The other path is integration via the standard MQTT protocol. This is a private highway. You have to build the road yourself.
MQTT. That sounds a lot more technical.
It is. MQTT is basically the common language of the IoT world. Choosing it means complete autonomy and control. You can connect your data to Alibaba Cloud, Tencent Cloud, or Amazon AWS. All of them support MQTT-based IoT services. Or to platforms like ThingsBoard or ThingsCloud, which are ready to use out of the box. Or even to open source favorites like Home Assistant. You can also connect it directly to your company's own private servers.
So the data fully belongs to you.
Exactly. The data is yours, and how you use it is entirely up to you. This path is designed for enterprise users or hardcore tech enthusiasts who need secondary development, data privatization, and deep customization.
I see. So no matter which path I choose, the first step is always using their official Yuanlai Intelligence app.
Yes, via Bluetooth.
Using Bluetooth to configure all the automation logic on the device.
Correct.
And then, if I want remote control or smart home integration, I switch to the Tuya Smart app.
Exactly.
If I'm a developer or enterprise user, I use MQTT to connect it to my own system. That design logic is actually very clear.
Yes, there's always an option that fits the user, which gives it an extremely wide range of applications.
Now, for tech enthusiasts who like to dive deep, that means getting into those pretty hardcore MQTT protocol documents. I skimmed through them and noticed a command called PWM control. That's a bit above my pay grade. Can you explain what it actually is and what kind of cool things it lets users do?
Great question. PWM in simple terms is like the brightness knob on the desk lamp in your home. But what really impressed me in the documentation is a parameter called PWM rate.
PWM rate?
It means transition rate.
Transition rate.
Exactly. And that's where the professional-grade design shows. Without a transition rate, a motor jumps instantly to the target speed, causing strong vibration and very rough behavior. But with a transition rate, you can make an LED gradually brighten over a minute or even an hour, for example, simulating sunrise and sunset lighting. You can also make a conveyor belt accelerate and decelerate smoothly, resulting in extremely fluid operation.
Wow, that kind of elegant control.
Right. That kind of elegance usually requires writing complex code and repeatedly tuning it in traditional systems. Here, they've packaged all that complex ramping logic into a simple parameter where you just enter a number.
That's exactly a bridge between simplicity and professionalism.
Exactly. That's perfectly put.
Wow, that really is clever. They hide all the complex implementation behind the scenes and give you just a simple control interface.
Yes, and there are plenty of similar hidden gems in the documentation. For example, the one-click execution command. It lets you remotely trigger a whole set of complex control actions that you've already configured in the app. Say a customer pays for a dog washing service. The server sends a start automatic washing command, and the pet washing machine executes a full, sophisticated washing sequence. That washing machine is essentially using IOTAutoMate as its built-in automation controller.
That's genuinely useful.
There's also OTA, over-the-air firmware updates. For traditional PLCs, this is basically a dimensionality reduction strike.
How so?
In the past, if you needed to update a PLC program, an engineer had to carry a laptop and physically go to the site. Now, you just click a button in your control system at the office, and devices thousands of kilometers away get upgraded instantly.
That's a huge improvement.
Of course, the documentation also highlights a warning in red: operate with caution. During upgrades, you need stable power and network connectivity. That's a very responsible reminder.
Right. Beyond software features, there's also a hardware highlight called mesh networking. I've heard of mesh before, but is there anything special about how it's used here?
The key difference is the application scenario. You can think of mesh as telepathy.
Telepathy?
Exactly. Each controller doesn't just communicate with your phone, they can also sense each other. When data changes on one device, it can automatically pass that information to nearby devices, which then relay it down the chain.
Ah, device to device.
According to the documentation, the visual transmission range for a single hop is 500 meters. With multiple hops, the theoretical coverage can reach up to 10 kilometers.
10 kilometers?
Yes, for large farms, factories, shopping malls, or building complexes, this is a game changer. You don't need to run hundreds of meters of signal cables, and you don't need to install multiple signal repeaters. The devices form their own network, and all of this works without relying on Wi-Fi, 4G, or any cloud server, enabling local device-to-device coordinated control.
That's incredibly powerful. All right, let's put all these pieces together and return to our core question. What problem is Yiche Intelligent Control ultimately trying to solve?
Let's look at the comparison chart on their official website. They compare themselves with microcontrollers and traditional PLCs. In my view, what they're really addressing is the issue of total cost.
Total cost?
Yes, a microcontroller development board might only cost a few dozen yuan. The hardware is cheap, but it's like buying a bag of flour. To turn it into bread, you need to invest huge amounts of time, manpower, and equipment for development and testing. The cost of the baker and the time involved is extremely high. That's why the documentation says the overall cost is very high.
I see. What about PLCs?
With PLCs, both the hardware and software development software are expensive, and you still need professional engineers to develop the system. Labor costs are high as well, so the total cost ends up being medium to high.
Right. And Yiche Intelligent Control positions itself as low total cost. It doesn't require specialized technical knowledge. Anyone can use it. So I assume the hardware itself isn't cheap?
As for the hardware price, I checked the purchasing channels. The base model starts at 239 yuan. That's far cheaper than traditional PLCs with more powerful features and no need to hire professional developers. It's more expensive than a microcontroller, but it dramatically compresses the most expensive part of all, the R&D cost.
Which is our time and mental effort.
Exactly. It lets you ignore the underlying code and focus entirely on the creative question, what do I want this system to do?
Of course, there's always a trade-off.
How so?
By choosing simplicity, you're also choosing to operate within its ecosystem, or its rules. If you need a highly specialized function that doesn't exist in its predefined building blocks, you may hit a wall. But in my opinion, for 95% of automation ideas, the functionality it offers is more than sufficient.
That's a very accurate summary. So its target user profile becomes crystal clear. It's not trying to replace high-end industrial PLCs on automotive production lines, and it's not trying to compete for the ultra-high-volume microcontroller market.
So where is its battlefield?
In the vast space between those two extremes, smart agriculture, intelligent buildings, educational labs, custom or non-standard equipment retrofits, and most importantly, entrepreneurs with great ideas who have been blocked by the barrier of programming.
In these fields, fast implementation, flexible modification, and low maintenance costs are far more important than microsecond response times.
Exactly. Different needs, different priorities.
So, just sum up our deep dive today. What it's really doing is one thing, providing a no-code solution for automation in the physical world through flexible hardware and two parallel software highways.
One leading to mass adoption through Tuya, and one leading to professional customization through MQTT.
It delivers on its promise of turning ideas into reality quickly.
In a corner of the documentation, I noticed a briefly mentioned feature called PID control. According to the materials, it allows rapid implementation of advanced control scenarios like constant temperature, constant pressure, and constant speed.
I've heard of PID. It sounds like a pretty complex algorithm.
Extremely complex. PID is one of the crown jewels of automatic control theory. From automotive cruise control to precise temperature regulation in industrial furnaces, it's everywhere.
That powerful?
Yes. It's a closed-loop control algorithm that requires deep theoretical knowledge and extensive on-site tuning. You could say PID itself is a very high technical barrier, the dividing line between amateur and professional.
Got it.
And now, this algorithm, which once required engineers to spend weeks tuning, has been integrated into a feature that can be configured through simple parameters in a mobile app. So let me ask you this. When these no-code tools designed for the physical world become more and more powerful, when even dragon-slaying techniques like PID are made accessible to everyone, what kinds of novel, intelligent automation systems will those once locked out by technical barriers create? Farmers, artists, designers, small workshop owners. If technological barriers are gradually removed, what would you want to create?